All right, thanks very much. My name is Paul Eggleton. I'm here today on behalf of the Open Embedded Technical Steering Committee to talk about high quality layers. Thanks to other folks in the TSC, especially Richard, for help with the material on this one. So what's the talk about? So let's consider this scenario. I've made a Yocto layer and it adds something kind of interesting. I think other people might be interested to use it. And hey, bonus, it actually builds successfully after a bit of hacking, at least for me in my configuration on my build machine. But how can we take that just working layer and turn into something great? A layer that other people are going to want to use. They won't hopefully make them angry or cause them to facepalm when they have a look at what's inside it. So I'm not going to be critiquing individual layers today. I'm just going to be keeping it fairly high level, talk about some of the issues and some of the concepts. So there's a few recent presentations in this space already, and I'm not just citing these are very much worth seeing. One I'd highly recommend is Paul Barker's talk, Creating Friendly Layers, from last year, the summit last year. Unfortunately, I don't think the video is available for that yet, but hopefully that'll come out soon. And also State of Bsps by Beth Flanagan from this year's OE workshop, and Chris Simmons, How to Write a Really Good Bsp Layer, also from that same workshop. There's going to be some overlap with those presentations, but I've got a slightly different focus here, so hopefully this will be complementary to those. So how did we get here? Yocto Project provides a hugely flexible and powerful build system. You can do all sorts of different things, but with that great power comes great responsibility. The build system, for a number of different reasons, is not necessarily going to enforce best practice all the time. That could be for performance reasons or just not closing off bits of flexibility that we still want to offer. So it's easy in inverted commas to produce something that works, but it might end up still being a little bit messy and difficult to use, and particularly difficult to integrate for a user into their own configuration. Really, I mean, there's nothing necessarily special about that. I mean, any piece of code can be that way. Of course, this is the embedded space, so there's quite a different there's quite a variety of different configurations, different use cases, different devices. So the environment that your layer might be going into could be quite different to what you necessarily expect it to be. Obviously, the Yocto project has a reasonably good documentation, I think, by now. It can always be improved. It doesn't necessarily cover all the best practices. But I would recommend it as a reference. So I think that if there's one thing I'm trying to emphasize, it is reusability. You want your layer to be reusable. And to kind of understand why it's important, let's explore a few things. So who is going to be using the layer? Who are your users? How are they going to be using it? What environment are they going to be putting it into? How will they enable it? How will they configure it? Will it integrate well with the other layers that they undoubtedly have in their configuration already? Just put yourself in their place for a moment and just see if what you're providing is going to be workable for them. What you really want is that your layer can be reused as is. Maybe there'll be some reconfiguration needed, but not substantial modification. So what does a great experience look like for a layer? It would be something like this in a perfect world. Download the layer from wherever it happens to be, add it to your bblayers.conf, add whatever the configuration is required to activate it, activate the functionality within it. So that should be, if we refer to the documentation, that should be enough to tell us how to do that. Bitbake, whatever desired image is, to include that. Flash that image to the hardware, or maybe start it up in QEMU, boot it up, and it works. And where it works means it added the desired functionality that we expected it to, and perhaps equally as important, didn't break anything in the existing configuration. So, I mean, obviously this is a perfect world scenario, and there's a lot of detail encapsulated in some of these steps. In particular, add required configuration and did not break anything. There's a lot involved there. But this is something I think we should be shooting for. So what are the common problems, pitfalls? It really mostly boils down to two different things. The layer is going to potentially making changes, assuming that it is the center of the known universe, that its settings are more important than anyone else's. So the desired configuration might be set unconditionally in layer.conf or in BB appends. It might introduce recipes that conflict with the same named recipe in other layers. Maybe it's a newer version, or perhaps even an older version, or it just has a different configuration. Secondly, the layer might be making assumptions about the configuration in which it's being put into. Perhaps it has been set up to expect certain distro features to be enabled, maybe certain recipes that it depends on from other layers. It expects certain package configs to be set in those recipes. Perhaps it points to some binary blobs and their APIs assumed to be a certain value, certain dependencies are available, etc. These assumptions might not be documented, and worse, if they're not fulfilled, then maybe instead of getting a nice error message, you get some obscure error and you really don't know what's going on. So really, we should properly answer this question. What is actually supported in this layer that you're providing? Document the supported configurations, document the environment in which you expect to support with this layer. And supported really means tested. If you're not testing this thing, then you don't really know whether it in fact works. So and you must document what you're testing. So the testing reinforces the support, and the support reinforces the testing, or the documentation reinforces that. Sanity, add some sanity checks that show clear error messages. so that the user knows exactly what's gone wrong. If there's something missing, it explicitly mentions that that thing is missing, and they know exactly what they need to do. They shouldn't be confused about whether things are going to work, whether this layer is going to work in their configuration, and if something goes wrong, they should know why the failure has occurred. So let's talk a little bit about structure. Yocto Project Open Embedded provides a number of different kind of orthogonal elements. That is, different software stacks, say, web server or some sort of language that you're enabling, basically, pure software. Separately to that, machine configuration, what is needed to support a particular target machine. Distro configuration, your desires and preferences and choices for the layout of the image that you're building, or the OS. And perhaps a fourth category is example use cases, demos, something to show your device, perhaps particularly if it's a BSP working in a particular scenario. In real usage, these are not terribly, they'll tend to get in the way. So try and keep each of these separate elements in a separate layer. A separate layer doesn't necessarily have to be a separate repo, but there should be minimal dependencies between each layer, and each layer can be reused independently if that's needed. And really, this kind of orthogonal concept is quite important in that you can swap out any of these axes, I suppose. You can change your machine without changing the software that you're running on it, for example. So if we don't separate these elements, we encourage forking. We're going to be encouraging the user to potentially have to change the content of the layer. They may even have to, if the structure is really poor, then they may actually just have to pull pieces out of the layer and create their own separate layer. So the fork might not even look anything like the original. And once you're in that situation, you've created a big maintenance burden. Next upgrade is going to be quite painful. And really the whole point of a layer structure within the Yocto project is to avoid the need to fork layers. You should be able to apply your customizations on top of layers more or less as they're supplied. So I'm not saying that users won't need to fork. Inevitably, you will need some updates as time goes on. Maybe you need to pull in some CV fixes or other fixes from upstream, but hopefully you're just pulling those from upstream and not making too many of your own changes. So let's consider along these lines some different layer types that line up with these. So first is a software layer. It only adds the software, that is recipes that implement that software or build that software, and perhaps some classes to abstract out some common functionality. BB appends, I'll talk a little bit about these later, but they should be probably kept to a minimum in software layers. They certainly If you do have them, they should only conditionally enable functionality. There shouldn't be any surprises when you add this layer in terms of changes to functionality and other recipes. So another type of layer is the Bsp layer, the machine support layer. This should similarly only contain what is needed to make the machine work. That is configuration, maybe a kernel recipe, additional drivers, perhaps bootloader firmware, that sort of thing. It shouldn't have anything, any applications or demos or change the system components. That's effectively distro policy. Really nothing that relates to the use case, to just about supporting the hardware. Every BB append or recipe that you put into this layer should be scrutinized to make sure it has a reason to be there and that it's implemented in an appropriate way. So one thing I want to call out is think twice about adding image recipes to your BSP. It's really, users are going to have their own image recipes. If you need to, it's better to influence the image contents from the machine side using machine essential extra rdepends or rrecommends that will pull in packages to the image. It might be okay if your image is intended just to test things. But if you're thinking about putting that in an image as some sort of reference, then it's going to be hard to separate necessarily the bits that are really important for supporting your image from the bits that are just nice to have or useful. Yeah, if you really need an image recipe in there for testing, probably put in a separate layer along with any other testing content. So third type of common type of layer would be your distro layer. If you're building a product, then you almost certainly should have your own custom distro layer to put your preferences into. And that, on the flip side, means that if you're producing any other type of layer, you should expect that the user will have their own custom distro layer that they're going to use with it. In particular, if you're shipping a BSP and a distro layer together, which is fine, but don't make the assumption that users are always going to be using those two things together. It's going to be almost certain that once they start doing something more concrete with your BSP, that they're going to switch over to their own BSP, their own distro layer, potentially one that they built themselves, or perhaps they're picking up one from an OSV. Distro layers are kind of a special case though. Deep customization is okay. You can machine specific customization on top of what the BSP layer does is okay. I mean, you're now building your use cases on top of the machine layer, so that this is the place you do that. You'll likely have all of your dependencies expressed in this layer because this is where you're bringing together the whole solution pretty much. Generic items should be elsewhere. If you've got some sort of support utility tool, that sort of thing, if it could be reused elsewhere, then put it in a software layer, I would suggest. Just to call out the Yocto Project compatible program, and which I'll talk about a little bit later, is does require distro layers to be conditional, just as with other layers. So your BB appends really should be checking, or should use overrides or checks to ensure that the distro is actually selected, not just in BB layers to pump. So making things optional, how do you actually achieve that? I'm not going to go into detail here, but this is a call out of the various ways you could do that. Which mechanism you use depends on the context. See Paul Barker's talk for a great coverage of these. So really the first thing to look at in a layer is the layer.conf. It's certainly one of the first things that Bitbait looks at. It's passed very early on in the process. It influences the global configuration. And you have to be careful what you're doing in here. If multiple layers start doing things and they conflict, the winner might actually depend on what order the user has put the layers in BB layers, which is not a great thing for getting a consistent behavior between the user and what you expect. So keep what you've got there to a minimum. Really do not be tempted to enable the functionality in there unconditionally. The user should always be in control. They should always be enabling the functionality explicitly. It's not just a matter of adding your layer and then something changes, and certainly not from here. If you do, feel like you want to add stuff here, think twice. Consider putting it in your custom distro configuration or the machine configuration or a common class instead, depending on what it is. There's two particular variables I'll call out. Layer series that appear in layer.conf. There's layer series compat that identifies the Yocto releases that this layer is compatible with, and it makes mismatches absolutely obvious if they occur. Just remember to keep the value up to date as you move to new releases with your layer. And layer depends, which expresses the dependencies that your layer has on other layers. BB files dynamic is one option to make these a little bit, to make the dependencies perhaps into soft dependencies rather than hard dependencies. You can activate parts of your layer depending on what's in the user's configuration. So recipes. Avoid introducing complete recipes where they exist elsewhere. Try and work with the other layer maintainer if you need changes in that recipe instead of copying it in there. I say avoid because sometimes you can't avoid this. If you must have it, just document why you've got it there, and then it'll be obvious to people if they come across it. Avoid, you could do an entire talk on this, avoid heavily forked sources. This is pretty common for the kernel and U-boot and that sort of thing. It's just technical debt for you and for your users. If you can work upstream, if that's at all possible, please do so. And really the way to make that practical is budget for that upstreaming in advance. Build it into your process instead of making an afterthought. There's a lot we could say about recipes, but this is not a recipe writing talk. So sanity check or restrict the recipe to a particular machine or host if that's appropriate. This is particularly important for machine or architecture specific things, binary blobs, drivers, and that sort of thing. You can also do a more complicated check if you want using anonymous Python by erasing skip recipe in case the condition isn't met. And this is quite a good way to do it because if the recipe is skipped, if you call for that recipe, if there's a dependency on it, or you explicitly try and build it directly, it'll give you an error, but otherwise it'll just be silently ignored, and that'll allow you to use other components of the layer if you're not using that recipe. So cross-layer dependencies can be another issue. Really, I mean, these are really how you will get, certainly one main way that you will get the source of dependencies between two layers. So they should be reflected at the layer dependency level, the layer level as well. Consider making these optional using package config, Pitfalls, dynamic, etc. And you can use Bsp Layer show cross depends to find these. So BB appends, much better than forking the recipe. Just to recap, they're just pasted onto the end of the recipe in ascending layer priority if there are more than one. You can change anything in the BB append, but you should make changes conditional. Typically, you would do this via overrides, but you could use inline or anonymous Python. And they do require maintenance. So obviously if the underlying recipe gets upgraded or renamed or removed in future, then your BB append will probably break. So it'll need fixing. So something to consider if you're adding classes, consider the scope that it'll be applied in. Is it inherited from a recipe, or do you intend it to be inherited globally? Depends what it's doing. Document that in comments in the class. Try not to overlay classes. This is bad practice because what I mean by overlay is have a class with the same name in your layer as another layer. So maybe you think you need to make some changes and you're just going to copy it and modify it. Classes are found by BB path, so BB layers order will determine which one wins, and then you're into another hard to debug situation for the user. Basically work upstream. Recipe name overrides. These are good for making small changes, but be careful not to if they don't get out of control. I was speeding up a little bit because I'm running short on time. By now you're probably thinking, surely we should have a tool to check a lot of these things, and we do in fact have a tool that is Yocto Layer. Checks the basics there, README, layer series compat, etc. One of the more interesting things does is it checks the task checksums before and after the layer is added. So you will see if there are any of these kind of unconditional things in the layer that are going to be potentially surprising. And it can be extended. It's also the Yocto Project compatible program. It's a certification program, not necessarily covering all best practices, but it's great as a reference, even if you aren't thinking about applying for it. So check that out. And make sure you have some sort of documentation in your layer, primarily the README that covers these items. And don't forget to add a few comments if there's unusual things in your metadata. And of course, if it's software, so if there aren't tests, then it may be broken. So make sure you add some tests. There's a few things here that you test a basic configuration and consider some of these additional tests. Basically building things that you wouldn't necessarily normally build. Doing world builds, changing distro features, different libc. And consider including these tests alongside your layer. Publish your layer on layers at openembedded.org, and do a few other things to make sure people know about it. So the few things we could potentially do in the future. This is harder than it ought to be. Unfortunately, I don't have time to go through all of these necessarily, but there's some work we can do, and help would be very much appreciated. So in summary, aim for reusability, document what's supported, test it, and use the Yocto layer to check your layers. Thank you. Any questions if we have time?